What is big O? Big O is a measure of complexity. And complexity is twofold. Number one, time complexity, how fast the algorithm runs. And number two, space complexity, how much space it takes in the memory. So we look at the measure of complexity in a worst scenario, which means in the worst case, how much time it will take for me to run this algorithm. And number two, how much space it will take in the worst case, which means in reality, our complexity may be smaller than what we come up with big O. So let's give a real world example. So let's say that this is a bookstore owner and his name is Oliver. And Oliver goes with the name Big O. That's his nickname. And he decides to use a data structure to record how much books he sells one day. So he starts from the morning and all the way to the evening until he closes, and he sells N books. So he decides to use a data structure, let's say an array. And array is a data structure, nothing but consisting of elements. Say that our array is called my sales, and his first sale consists of 1 book, his second sale was 3 books, third sale 4 books, and fourth customer didn't buy anything, but that's okay, and so on. So this is his array. Okay, so let's look at the time complexity of these 3 scenarios. The first scenario is a function of first sale. So my first sale. So my first sale function will be resulting one number, which is the first number 1. So how do I represent this in Python? So this is pretty language agnostic, so you can use whatever language you would like. Since Python is a zero index language, I'm gonna call the 0th index to find my first sale. So it will be my sales 0. So now let's think. If my array was this big, just only consisting of 4 numbers, versus say that my array is now thousands of books, right? Does it make a difference for me time-wise to go and find the first element with a small array versus big array? In other words, when my n increases, how much my complexity changes? That's the one big question big O answers. That's all we are doing, right? So since it won't change how much time I spend, what do I call this? I call this a constant time operation, which in big O terms, how do we write this? O sub 1. So the second one, he wants to know the total number of sales. So the function will be total sale. So how do we come up with it? We are writing a sum function. Sum will be my sales. And now let's think. If number 1, it's a small array, just 4 elements. Number 2, it's a huge array. My sum operation is going to change in a linear relationship with this total sale function. So I'm going to call this a linear time operation. Why? Because when my n increasing, my complexity is going to be increasing linearly in the worst case. So I'm going to call this O sub n as a linear time operation. Number 3, he wants to sort this from smallest to the largest with a so-called bubble sort. So there are a few different sorting algorithms. We are here talking about bubble sort, which is relatively slower. So what bubble sort does, it's looking to adjacent numbers and swapping it if the second one is smaller than the first one. So we are doing this in the entire array, and then we are going back and reswapping the adjacent numbers if they are not in order. So this function, say that it's going to be called bubble sort, and it will be a quadratic time complexity, which we will be writing as O sub n squared. So this is big O notation in a nutshell. This is extremely useful in terms of how we judge the performance of the algorithm and how much space it takes.